This is a verbal walkthrough from the Power Unit Simple Machine module designing a factory subsystem. Make sure to download this file into Notability. You can read or listen to the story below. Aisha makes work easier to understand the need to design a factory subsystem. You will need to 1. Describe how Aisha used the design process. 2. Identify the simple machines used in the book and explain what problem does it solve. 3. Match vocabulary definitions. 4. Imagine what materials you can use to create a factory subsystem. An entire factory is called a system. It is made of lots of smaller systems called subsystems. Industrial engineers often work on subsystems to make work easier and more manageable. Your system must move a box over to a table and then be lifted up onto the table. 5. Draw a diagram of your factory subsystem. 6. Get feedback from classmates. 7. Build your factory subsystem. 8. Reflect on if there are any areas you could improve on. All of this evidence should be seen through your work in Notability. The engineering design process. 5 steps for engineering design. Ask, what's the problem? What have others done? What are the constraints? Imagine, what could be some solutions? Brainstorm ideas and choose the best one. Plan. Draw a diagram. Make a list of materials you'll need. Create. Follow your plan and create it, then test it out. Improve. Make your design even better, and then test it out again. Aisha and the engineering design process. Directions. In the boxes below, write or draw a picture explaining how Aisha completed each step of the engineering design process. On the left are the steps of the engineering design process. Ask, imagine, plan, create, and improve. How did Aisha complete each of these steps? Aisha spies simple machines. In the left-hand column, what simple machine is used? There's the lever, pulley, inclined plane, wheel and axle, wedge, and screw. In the middle column, where is the simple machine found? What is its common name? And in the last one, what problem does it solve? Vocabulary definitions. Aisha makes work easier. Directions. Match each word to the correct definition listed below. Our options are pulley, simple machine, technology, subsystem, lever, engineer, and industrial engineer. 1. Anything, system, or process that people design to solve a problem. Pulley, simple machine, technology, subsystem, lever, engineer, or industrial engineer. 2. A simple machine that is a board or bar supported by a fulcrum. Pulley, simple machine, technology, subsystem, lever, engineer, or industrial engineer. 3. A smaller part of a larger machine or system. Pulley, simple machine, technology, subsystem, lever, engineer, or industrial engineer. 4. Someone who improves systems to make work easier, faster, or safer. Pulley, simple machine, technology, subsystem, lever, engineer, or industrial engineer. 5. A machine that makes work easier, such as a lever or wheel and axle. It does not have any moving parts. Pulley, simple machine, technology, subsystem, lever, engineer, or industrial engineer. 6. A wheel with a rope that runs around it. Pulley, simple machine, technology, subsystem, lever, engineer, or industrial engineer. 7. A person who uses his or her knowledge of math and science to design things or processes that solve problems. Pulley, simple machine, technology, subsystem, lever, engineer, or industrial engineer. Improving a factory subsystem. Engineering design process. Ask. 1. Our goal is. 2. What materials can you use in your factory subsystem design? 3. Some things we already know about simple machines are. 4. How will you know if your design is successful? Improving a factory subsystem. Engineering design process. Imagine. Page 1. What simple machine do you have to use? What other simple machines can you use? Draw pictures or write your ideas in the box below. Circle the idea that you think will work the best. Improving a factory subsystem engineering design process plan. Directions. Draw a diagram of your factory subsystem design in the box below. Label the parts. 1. List the simple machines you will use in your subsystem design. 2. List the other materials that you will need to build your subsystem design. Contractor feedback form. Have classmates look at your design and see if your factory subsystem will work. They will play the role of the contractor and you will be the engineer. Contractors' names, engineers' names. 1. Does the design look like it will be successful? 2. If not, what do you think might be the problem? How do you suggest the engineers might fix this? Draw any design ideas you have to help them. Improving a factory subsystem engineering design process create. 1. The total score for moving the load by hand was. 2. The total score for our subsystem design was. 3. What happened when you tested your subsystem design? 4. What parts of your design worked well? Why do you think so? 5. What parts of your design did not work well? Why not? Scoring sheet. Directions. Complete the table below after you have tested your subsystem design. Reminder, when you are testing, a lower score is better. In the left-hand column, there's the force score. What was the total force in newtons needed to move the load from the floor to the loading dock? If you used more than one step to move the load, add all of the forces together. Ergonomics score. When moving the load, did you have to bend over? If you did, that would be an additional 2 points. Pull upward. If you did, it would be an additional 2 points. Push the load. If you did, it would be an additional 2 points. Or pull downward, which would also be a negative 2 points. Total score. Add your force score and ergonomic score. In the middle column, moving the load by hand, and in the right-hand column, moving the load using a factory subsystem. Improving a factory subsystem engineering design process improve. Ask again, what parts of your factory subsystem design could work better? Imagine again, how could you improve your factory subsystem? Plan again. Draw a diagram of your improved subsystem design in the box below. Label the parts. List the materials that you will need.